Welcome to Cheap Controls. We make videos on things that we struggled with, hoping to help you so you don't. Consider subscribing and hitting that bell. In this video, we're going to take a step further. A few videos ago, I created one on a countdown timer where it was just simple. We set a time on the Nextion display, sent it to the Arduino. The Arduino counted down and then turned on an LED. A viewer pointed out the fact that I had something wrong in that video, that if you entered an hour, it didn't work out right. So we're going to address that in this video. We're going to start in the Arduino. We're going to pick right up from where we left off. And in the last video, we adjusted the length of the delay here. When we initially start this video, we started at a 500 millisecond delay, or half a second. So every half second we're going to do something. We have a built-in delay that will accomplish a task every half second. And in the last video, the time that we sent from the Nextion back, we adjusted this. Well, this works if all you're doing is just doing that one thing, where you're turning on an LED or a motor or something like that. But in this video, we're going to send feedback back to the Nextion, and we want to send that at a faster rate maybe than what we set our timer at. So we're going to add a second variable here. And the CD timer variable, or countdown timer variable, is going to be based upon what our async delay is. We're going to add a value to that async delay variable up here to compute this CD timer. So this CD timer value could get rather large. So we're going to call it an unsigned long rather than an int. In this function down here, or this if statement, this is where we compute the delay length right here. So we take the delay length and we get the data from display and we convert it to an int and we multiply it times 1,000 because it comes in seconds and we got to convert it to milliseconds. So we're going to comment this line out, and then we're going to add the two lines to compute the CD timer. So in this, when I add these two lines, we're doing the same thing we did up here with the delay length. We're taking the CD timer and we're going to take the data from display, convert it to an integer, and turn it into milliseconds. But then down here's the difference. And this is why I had to use the unsigned variable, or the unsigned long, because when I add the milliseconds to it, the number could get very large. And what we're computing is the time in the future, because when this is tripped, we instantly turn on, by this timer enable and writing to the output high, we turn on the device. So we want to know when we need to turn it off. And that's what we compute right here. And then we're going to print that value out, just like we did on the delay length, but instead we're going to print out CD timer. We're only going to look at this string if there's an issue, so it's just for troubleshooting purposes. But now we have to go down to the async delay and alter that a little bit. Because we were altering this delay length before, and now we're not doing that anymore. So this is going to execute every 500 milliseconds just because that's the way we have it set up, and we're not changing it. So we're going to take this if timer enabled statement in this area down here, and we're going to make it its own if statement. So we'll take it out of this one, out of the async delay, and move it. But now this is going to loop through every time we run through the loop, which is going to happen on the microsecond level. So we don't want this to disable the timer instantly after the timer is enabled, so we have to add something to this if statement. So not only are we going to check if the timer is enabled, but we're also going to make sure that the CD timer is less than the current milliseconds. Because when we enabled the timer, we set this CD timer to the milliseconds plus a future value, or plus a value that set this time in the future. So if that time is expired and the timer is enabled, we're going to make the timer enabled, setting it to 0, or disabled, I guess you could say. And we're going to digitally write our output to a low, and then we'll just locally serial print the timer's done. Once again, just for troubleshooting. And line it up a little bit better. I'm going to upload this now and move on to the Nextion. And just to make sure that we didn't break anything, I'm going to run this in debug and check it out and make sure that it works just like it did before. Because on the Nextion side of things, we really shouldn't see anything different. But I'm also going to show you the error that if we do the hours. In order to show you that, I'm going to have to add a number field down here. And we're going to set this number field when we click the start timer. So we're going to leave this all the same right now. The error is in this line right here. So if you want, you could pause the video now and see if you can figure out where it is in there. But I'll get into that here in a little bit. But for right now, I just want to show you the error. So we're going to add a line here where we're going to set the value equal to the value of the variable that we're sending over to the Nextion. And this is the final value after all the math is done. So we'll run this in debug now. Okay, so I have the Arduino set up on a camera over here, and I have the blue LED that'll come on when I hit start. But the first thing I want to do is I want to show you the error that I have. And we get that by setting the hours down here. It went seconds, minutes, and hours. So I'm going to select the hour and increase it by 1. So this is 1 hour, and the math should show that it would be 3,600 seconds. But when I hit start, we're going to write the second value that we're sending to the Nextion, or to the Arduino. And it's 216,000 seconds. And I believe that that's 3,600 times 60. And that's the math that's wrong in the equation. And we'll fix that here in a minute. But I'm going to set this back down just so that we can verify that it's still working, since we moved to the timer and we've switched it from the async delay to the countdown timer delay. This will be a 5-second delay, and this should change to 5. And it did. Oh, but I got to connect this up. So go down here, and we have the Arduino set to COM5. That serial 2 is running to a USB converter into the PC. So I hit start. You can still see the LED, so I'll just leave it like this. When I hit start, the LED comes on, and it should shut off in 5 seconds. So everything's working well, but there is a problem, and it may not be a problem depending upon your situation, because every time I hit the start button, it's going to add 5 seconds to the LED. So if I hit start, as long as I keep hitting start, it's never going to shut off. So it just extends the delay by 5 seconds. But there may be a time where you hit it once, and let's say you double hit it or something, but you only want it to run for 5 seconds. So once it's hit once, you don't want it to be able to reset that time. So we have to go back over the Arduino, and I'm going to set it up that way. So if I hit the start a second time, it doesn't alter the time that the delay or that the LED is on or the motor is running or whatever it is you're controlling. So I'm going to close out of this and go back to the Arduino. And we're going to make this adjustment where we collect the data. The way we collect the data from the Nextion into the Arduino is we collect it 1 character at a time. And if there's that 1 character is available, we write it to the data from display. And then once we get over 7 characters, or in this case 8 characters, we do this if statement down here. But all we have to do is add this 1 line. So if the timer is enabled, then we just reset the DFD. So every time something is sent to this serial port and the timer is enabled, we're just going to drop it or ignore it. So in this way, when the timer is enabled, if we hit the start button again, we're not going to alter anything. We'll go back to the Nextion and test this. So now when I hit the start button, the light should come on, but you should see it flicker if I keep pressing it. And it went back on. Because I don't have any delay, the second the enable goes off, it takes that start button again and starts again. What you could do is, on the instance where the timer gets set to 0 or is off and it accepts this button press, you could add a second delay that says, once that I've run the motor or turned the light on for so long, once it goes off, I don't want it to come on and have a second delay of like a second or a minute or whatever it is you want. So you could take this even further if you so chose. But we're going to leave it this way because I don't like the fact that the timer can keep extending itself. I want to see some feedback that it went off. And now we're going to fix this issue with the hours. And as I said, the issue was in this, and it's this line right here. When va0.val is equal to the hour.val times 3600, that line works well. So if I have 1 hour, it's going to be 3600, which is what was the example I used, was 1 hour. But when I come down here and I take this va.val plus equal the minutes, or the value that's in the minutes over here, and then I multiply it times 60, I thought that it would be like doing this, with the parentheses around it, that it would take the minute value times 60, and then it would add it to this value, this 3600. But it doesn't work that way. It works more like this. va0.val adds it to the minutes. When we had the hour set to 1, it was 3600. So the minutes were set to 0. So 3600 plus 0 is 3600. But then it was multiplying it by 60. So it's taking that 3600 times 60. So if we had increased the minutes, let's say we had 10 in the minutes, it would have said 3600 plus 10 is 3610, and would have taken that value times 60. And there's no way to alter this equation if you try to alter the equation to force it to do this multiplication before it adds it, you'll get an error. I'm going to compile this. And down here you can see that you get an error. It just doesn't work that way. So what we have to do is we have to add a second variable, or a third variable. This va2, we're going to make it a number variable. So now we have a number, a string, and a number. And this, when we press start now, so instead we're going to take va0 and we're going to compute it to the hour.val times 3600, because we know that that works. But then we're going to take va2 and make it equal to the min. We don't need this plus. We're going to make it equal to the min val times 60, or the minute value times 60. So we'll have two separate values. We can add those two values together. So va0 is going to be equal to va0 plus va2. And then since we don't do any math on the seconds, we can do the same thing down there. So now when we print the value out, it should work just fine. We're going to run this again, and I'll show you. I'm not going to show you with the light because I'm going to add hours, but I'll show you that it does work now. So we'll set this equal to 1. We'll hit start, and you'll see that it's 3600 now. So that's good. And then we're going to add 1 minute, which will add 60 to it. So it'll be 3660. And then we're going to add 6 seconds. So it should be 3660, or 3666. So now we have everything working. And if I connect this up and hit start, and then press start here, you can see that the light is on. But let's change this just to make sure the light will go off. Oh no, it won't now because I've set it to where I can't adjust this anymore. Once it started, so it's going to ignore everything. So the only way to do this now would be to reset the timer, or the Nextion, or the Arduino, I mean. So now if I hit start on here, that should shut off, and it does. So we're back to working, and we've got the hour field fixed. The next part I want to work on is a little bit of feedback so that we can send a value from the Nextion, or from the Arduino to the Nextion, so that we know that there's a connection between the two. We're going to do that. We're going to go to this program s.tab, and we're going to add a variable up here. We could use a variable that's already created, but I thought it'd be fun to make our own. Whenever you add a variable in here, it has to be above this page 0. And you also can't add any sort of a string variable. It has to be an int. We're going to call it cheap controls var for cheap controls variable, and we're going to set it equal to 0. So we're going to assume that the Nextion is not connected at this point. So now we have this variable that we can use. We're also going to use a timer to check that variable and see how its status, see if it's a 0 or see if it's a 1, and then based upon that timer we'll have an action. So in other words, we're going to use that variable to gather data from the Arduino, and if the Arduino is updating that CC_var, then we know that there's a connection between the two, and we're going to use a timer in the Nextion to test for that. I'm going to set this timer to check for every 3,000 milliseconds or every 3 seconds. So if the Nextion or if the Arduino loses connection, then it'll take 3 seconds to update. So in other words, it can be down for 3 seconds, and you could adjust this to whatever you want, but just for the ease of the video I'm going to set it to 3,000. So when this timer times out, we're going to have it turn the start button to red. So after 3 seconds, the start button should turn red. And what we're going to do is we're going to look for a signal between the Arduino and the Nextion. If I haven't seen any signal between the two or a key from the Arduino, after 3 seconds I'm going to turn this start button to red. We'll run this in debug and I'll show you that it works. So simply after 3 seconds this should turn red, and it does. So now we have to figure out our logic that's going to stop that from turning red based upon input or a signal from the Arduino. And we're going to use a second timer for that. Add another timer. So in this timer we're going to set it equal to every second. This timer, since it's going to be doing a test to control this timer, it has to run at a faster rate than timer 0. So this has to be able to update timer 0 quicker than timer 0 can execute. I hope that that makes sense. And then the code for timer 1 is this right here. So we're going to see, and if CC_var is equal to 1, in other words, if it's set to 1, which it isn't right now, but if it's equal to 1, then we're going to stop timer 0 from functioning. And we'll do that by enabling it. When you enable a timer, you reset it back to 0. So timer 0 is trying to count to 3,000. If I send an enable signal to it every second, it's never going to count to 3 seconds because it's going to keep getting reset to 0. But in this case, since CC_var is equal to 0, it's not going to send this enable, so it's going to allow it to count up. So right now, if we were to start this, even though we have this timer 1 set, it's not going to act any different. It's still going to reset the start button or set this to red. And you can see that this will change to red. So now we have to go over to the Arduino and send a signal to it so that it sets that CC_var. So it sets this global variable equal to 1. And what I need to do though is this timer 1 is setting it to 0 down here. So I have to make sure that the Arduino sends the signal fast enough so that it executes this. So in other words, I have to set the CC_var equal to 1 in a quicker time frame than this timer 1 times out. So it has to come in faster than a second. And this is going to work out nicely because we have our async delay in the Arduino set to every half second. So we're going to go over there next. So we're going to use our async delay for this because it's already configured. This is going to execute every half second. We're going to send 2 lines up to there. First line, we're going to set the CC_var equal to 1, and we're going to send that every half a second. So we're going to set this, the second line, we're going to set that button to green, that start button to green. So originally that button is going to be like a white color or kind of a light gray, and it's going to change to green the first half second that I connect it to the Arduino. Well, actually, if I don't connect it fast enough, it'll turn to red, and then once I connect it to the Arduino, it should go to green, and it should start setting that variable equal to 1. So let's go back and test this all out. Okay, so now we have it all set up. This should go to green, or to red, I mean. And now I'm going to connect this to the Arduino, and then the Arduino is sending the signal every half second, so this should change right away. And you can see it changed. A little flicker there. That was kind of strange. It went to red to black. But I guess it would depend on the timing of everything and how fast, because I sent that start up. If it didn't change that CC var right away, there could be a little bit of a glitch there. But it'd be better to see that it's offline when it's actually online, to see that it's online when it's actually offline. So now we have this feedback. If I were to stop this in 3 seconds, this should change back to red, and it does. And then if I connect it back up, it turns right away. Everything seems to be working well. Now what we're going to do is we're going to put a little feedback back from the Arduino, and we're going to change this to a text field, and we're going to have it count down the number of seconds. So if I set this to, let's say, 5, and I hit start, we don't really know how long that is. So we want it to count down, or we want to show a countdown. So I'm going to do that next. We're going to delete this number field. Oh, we better go in here first. Delete this. We're going to add a text field. So we have this text field. We're going to initially set the text to off. Just so we have something in the field. And now we don't really have to do anything in the Nextion. We have to go to the Arduino, because the Arduino is going to control this field. We want this to update not down here, because this timer enable where we disable it, that's only going to run when it times out. So we're going to do this into this async delay. So we're going to send the signal back to the Arduino every half a second. So when we run through this, we only want to do it if the timer is enabled. So every half seconds, if the timer is enabled, which means it's counting down, we're going to make a variable called cd var for countdown variable. And we're going to take the current countdown timer, we're going to subtract, or we're going to take the value of the countdown timer, we're going to subtract the current milliseconds, because this is continuing to increment. We're going to divide it by 1,000 to get it into seconds. And then we're going to add 1, because otherwise it would be 0 based. And then we're going to convert that to a string, and we're going to place that in t0.text. When you're doing a string, you have to escape a quote, because you have to send a quote, and you can't just put it in there. So you have to put that / quote on both sides of it. So you have to add it over here too. And then once it times out, we're going to want to set that text box back to off. So when we enable it, or we set it back to 0 and we turn off the output, we're going to send to the to.text, we're going to send the value off. So now we'll test it all and see if it's working. So this should turn to red. I'm going to let it go. And now we'll connect up. So now we have our timer running. And let's just set it to 3. And we've got a countdown, 3, 2, 1, and then off. So it seems to be working. And just to test, let's add an hour. So this would be 3,600 times 2, which is 7,200, plus 1 hour, which is 60, so 7,263. So this should be 7,263. There we go, and it's counting down. So now what we have is we have a countdown timer, which we can adjust and set, send the value up. That actually works with hours now. And we get feedback from the Arduino. Because even right now, if I hit stop and I lose the connection to it, this has stopped counting down, and this should go to red. But now if I connect it back up, this should catch up, and it does. I'll do it again. I'm going to stop it at 30. We'll wait 3 seconds, and then I'll hit start, and it should be about 72.25 maybe, 23. But you can see that it works, and the Arduino keeps running, and that's what's nice to get a little feedback, and why we want the timer functionality in the Arduino. So if we unplug or something happens to the Nextion and we're controlling something that's important, it'll continue to run. Not that I would say you should use an Arduino or set up like this to do something that could cause injury to anyone. I would drastically not say to use this for that. I would go way deeper into some sort of a error scenario where you've got some more safety precautions. This is a good example of showing feedback and control between the Nextion and the Arduino. Well, that's about it for this video. If you like what you saw, consider giving me a thumbs up, and also consider subscribing to the channel. Thanks for watching.